Well, hello, good morning, everybody. Thank you very much for making the time to join me on this webinar in partnership with Testmeter. I'm just going to give it a couple more minutes, just obviously to make sure for those few late arrivals having any problems. So we'll just be patient and give it a couple of minutes and we'll start just after past. Okay, we'll give it just one more minute and then we'll make a start. I value everybody's time, so don't want to delay it too long, but just give people another minute. Okay, well, it's just gone to 31 minutes past, so we'll make a start. Good morning and welcome to everybody for joining me. My name is Marc Sherwood. I'm the Senior Technical Sales Manager for the UK and Ireland. We're hosting this event today in partnership with a company called Testmeter. And obviously, I'm going to give you a presentation around our new Fluke solar tools. Now, obviously, feel free to ask questions and put them into the chat. I would prefer to go through them at the end if that's okay. But I will keep sort of looking to the right just to see if anything comes up that's pertinent to what we're doing at the time. The last couple of slides of the presentation today will contain two sheets. One of them will have my details and my colleague for any technical questions you may not want to ask in person while we're running the webinar. And the second one is for our partner today, Testmeter. There's contact details for them where you can reach out to them directly and obviously approach them for pricing issues, etc., and any other additional support you may need. So with that in mind, I'll make a start. And like I say, those last couple of slides, I'll leave them there for a good minute so you can make note of those details as well. The session will be recorded today, and on completion of this session, you'll have the opportunity to take it and download it, etc., for your later viewing. So with that in mind, let's get started. So what we're going to go through today, I'm going to talk to you about solar energy, specifically around market sectors, using and troubleshooting with our solar SMFT-1000, and obviously how to test it, etc. as well. So I'll just go through this. So a basic solar overview. What we're looking at here, we're looking at obviously capturing the sun's energy and turning it to electricity for your home and business. Typically, we relate to this in three specific sectors. Firstly, residential. Speaks for itself, it's the domestic dwellings. Then we move to more large commercial industrial units where we see new builds and new factories trying to harness some of that sun's energy and capitalize on it for running their own plant or feeding into the grid. And then we have the more larger utility scale applications. Irrespective of size, these all pretty much operate on exactly the same testing system and require the same tests to be conducted. It's just purely down to the size or the scale of the solar panels. So to talk about solar energy, I think it's important to see what kind of level this captures within the global market. Just a few basic stats from a couple of years ago here. It's plain and simple that renewable energy or clean energy or green energy, as we like to call it, generally constitutes round about 29%. So it's heading towards a third of all electricity generated in that year. Now this, they do say, is rising at roughly between 25–27% per year. And of that 3% roughly, you're looking at round about just over 10% of that is being contributed from solar. That number is steadily on the increase, as we appreciate. So what can we say about solar in the UK? As of 2021, I've been able to get a few slightly newer numbers here, but at the moment we're contributing around almost 15 gigawatt of energy is coming from solar capacity now. This again, as I say, is generally increasing round about by, well, 3/4 of a gigawatt basically from solar PV captured up and down the UK. At the moment, domestic dwellings contribute for just under 1 million UK homes, and that constitutes round about 3%. So obviously you can see we've got significantly more potential there for solar panels to play a larger part in generating for not just individual personal use, but obviously for the contractors and the test and measurement sector, where obviously serving, pardon me, servicing and obviously maintenance takes place. On the larger scale, we have at the moment round about 500 solar farms operating up and down the UK. Obviously, these feed clean energy into the grid. We see these on, as I showed you on the illustrations, big solar farms by the sides of UK motorways, and obviously on large industrial units as well. So what do we see from solar trends? What we're seeing now is a big demand, obviously, as people are moving from 1,000-volt systems, pardon me, to 1,500-volt systems. This is becoming more and more the normal, especially around PV installations. Why is that? Well, it's because obviously solar panels, as you'd expect them, like most technology, is improving. All the time it's making advancements. So what we see now is that they're moving to these more efficient, slightly smaller panels where they're able to maximize the voltages that can be obtained from them. So now you're able to generate more power from fewer panels, or more panels with obviously larger potential to gain you more feeding into these larger generating solar farms as well. So overall, there's much more clean energy coming into the grid. Following on from that, what we like to focus on is the type of safety ratings associated with testing of these installations as well. Where you come to do all electrical measurements and electrical testing, there's always an IEC standard in relation to that. The one for photovoltaic panels is 61730-1. And this defines very clearly around the insulation of those panels, creepage or foliage, etc., where they're starting to be, clearance requirements, and obviously protection for over voltages, etc. So with this in mind, we recommend and align with that standard, a category instrument is used to test it. And again, this is the most important. We've seen obviously a number of tools been introduced to the market over several years where category ratings are not becoming the primary consideration. So we urge you to make sure that you use the right rated category instrument for the right application and the right environment. So just to focus a little bit on the type of installations you may typically come across when it's coming to test. These are all relevant to our SMFT-1000. But to focus here, this is a very neat slide, I feel, as it offers you a number of different points in a very clear illustration of where you would obviously have to measure at multiple points, where you may have to install your PV tester and keep an eye on it. Obviously, you're going to capture lots and lots of information. So you're going to need to capture these results. You may even need to go through reporting. And again, this may necessitate some kind of obviously software or CMS package, basically, that's appropriate for yourself. But I do like the illustration. It gives a very clear graphic of how the system itself flows on a domestic installation. The same system applies, obviously, to a commercial or business venture. Again, this one still requires the 1,500-volt PV systems. We need to look for degradation of panels. Again, lots of data to be captured, lots of reporting to be done, and obviously software package to retain this. As I said at the very beginning, all these types of installations of solar panels mirror each other. It's just on the scale of which they operate. So again, this one here is on the utility side. So again, there is no changes here from the 1,500-volt systems. If you like, taking measurements, obviously there's going to be various other additional units, more splitter boxes, more junction boxes, more inverters potentially, but the system as a whole remains identical. So to test a solar panel in the UK and also around Europe, we do still need to comply to a standard, as I've said. There are standards for the panels themselves, but there are obviously testing procedures and testing standards. This is 62446-1. This is a European harmonized standard here. As you can see, it's part in English, and obviously there's some French and Spanish versions in here as well. So what do we need to do just before we move more into the tester itself? So when we come to test these installations, and whether it be in commissioning or general maintenance, we do need to verify and conform to that standard I mentioned, 62446-1. Those standards are clearly defined, and it requires that you test AC circuits and then followed by 6 additional DC circuit tests. These need ideally to be performed in an order, and going through them in an order obviously allows you to safely do these tests and perform them to the standards that are required. So to list them down here, you can see that the first test that they recommend is testing for the continuity of that installation. That includes the grounding conductors as well as the equipment itself. Then you're going to head towards polarity testing of all the DC systems and all the DC cabling. You then would look for open circuit voltage, or VOC, and this is going to be for each photovoltaic source that you would have on the circuit as well. Following on from that, test number 4 is for the short circuit current, or ISC. And again, that's for each PV source circuit as well. And then we're going to test for functionality. Functionality is obviously one of the most critical things. I'm sure for those of you that have been involved with electrical testing over years, everything can appear to be electrically safe, but units sometimes just don't work, even though they're electrically sound. Then we need to do a final test for insulation resistance of that DC circuit conductor as well. So those are the primary 6 tests that need to be performed on the DC circuit. There is a 7th test, and the 7th test people say is probably the most important one as well, for obviously understanding what's going on. What's going on with the solar panels, and obviously what they're outputting. And this is the full IV curve trace. The IV curve trace is going to be looking at the efficiency of the panel and obviously how it delivers this energy back through the system to your benefits. So safety and performance testing, as I highlight there in yellow. Performance testing is during installation, commissioning and maintenance, ensures safety, reliability and the longevity of PV installations. That's what we're talking about, and that's why we perform these tests, so that we can maximize their output and we can keep them operating at their most efficient. So what do we do to test a solar system? The first thing we do on a safety system is testing at the mains installation. So again, as you can see by a typical illustration here, yeah, you have the mains distribution box and we have socket outlets as well. But this is where it's being fed from the public grid into your property that's actually using this from an AC side of the system. This must comply to an IEC standard, and that's 6036-4-6, as you can see. Now, I did say again at the beginning of this, you can take this presentation away after the session, so don't need to write too much down at this as we speak. But as we perform this, then we would move to the tests themselves, as mentioned just. So you've got the continuity of the protective conductors. You will look at the insulation resistance. Then we'll do the voltage check and the current check. Then we'll look for diode checks. And then we have both voltage and current for AC and DC tests. All these tests and that performance there can be conducted using our new SMFT-1000, as you see there on screen. When we come to doing more safety testing, and we're looking at the inverters, etc., this is where we've obviously got DC circuits as well. And again, we're going to conform to the standard as laid out there, 62446-1. This one then would include testing of the continuity of the protective conductors and insulation resistance tests. Again, these are on the DC circuits, protection against earth for earth. Utilizing, as said, our new SMFT-1000 unit. Then what we move to is some parts of the functional testing of these. Again, on the DC circuits, conforming to that standard again. And again, these would include polarity test, testing of the open circuit voltages from these as generated from the solar panel itself. Then we're looking at individual string currents, short circuit or operated at the general solar current. And then we have an additional meter, or solar irradiance meter, and a solar temperature module included with that. So to support the use of the SMFT, we have the Fluke IIR2 BT. BT standing for Bluetooth. And then we have our solar clamp meter, the Fluke 393. Both these meters I'll explain a little bit more of shortly. Then we have a functional test. Again, it forms part of the standard we want to test to, and it could also include part of the IV curve test and an IR inspection. For this, we recommend the use of the thermal imaging cameras. We've specified, well, I say specified, we've advised on 2 units here, the TIS55 Plus and the TI75 Plus. The reason for this is these are both very robust cameras with good, strong functionality and able to deliver the job in the environment asked. So we have the SMFT-1000. solar tester, performance analyzer, and more importantly, an IV curve tracer. So what will the unit allow you to do? It will allow you to test category 1 tests in accordance with the IEC 62446-1 standard. This is where, again, apologies for being a little repetitive, but this is where it will allow you to test for protective resistances, voltage of these open circuits, including polarity, short circuit test currents, and an insulation resistance test. That is what we call the category 1 test, where you would need the SMFT. We then have category 2. Category 2 is the additional tests that are required for you to do this, and therefore you would need additional units. Now, for category 2, the main feature that sets the SMFT aside from some of its other competitive units out there is it illustrates the IV curve trace on the unit itself. As you can see by the illustration on the left, bottom left, you can see the IV curve on screen there as we speak. From this, you can do true analysis, download via the software using our dedicated TruTest software. For additional parts of the performance and functional test, you would also utilize the irradiance meter, which has the inbuilt temperature and can include tilt and azimuth, which is bearing conditions basically as well. Bearings as in where you actually are in location. So just to highlight it again, one of the standout features that we have is the IV curve trace is on screen here as well. So TruTest with the SMFT. Now, Fluke offers the TruTest software. It's designed to work completely in conjunction with the SMFT. Where does this come into its own? It's because it has a number of what we call STCs, or standard test conditions. These STCs are delivered by the producers or manufacturers of the solar panel to give the IV curve trace. So we're looking at the performance of them. These modules or standard test conditions are able to be uploaded and downloaded from the unit into the actual unit itself. So you don't need to carry extra paperwork, you don't need to carry any additional documentation. It will all and can be kept within the unit itself. And these standard test conditions relate to a 25 degrees centigrade at 1,000 watts per meter squared. That is a standard test condition, basically, that all panel manufacturers have to relate to, and that would show the profile of the IV curve. So where are we going to do this testing? Well, again, as I mentioned previously, we've obviously got the solar panels themselves. We're going to focus on you testing at the combiner boxes. We have battery storage to factor in as well, where there's potentially larger scale storage. And again, more inverter boxes, and then distribution of what you have feeding from the grid via substation and transmission lines on a utility scale. So for solar panels themselves, what do we have? We have the requirement to check that they're actually doing what you want them to do. Do they work? Is there actually feed and power coming from them as well? For this, you would obviously need to utilize things like the solar clamp meter that we have, the 393. You may want to utilize thermal imagers as well. And again, this would help you all to trace out the wiring from obviously all these different points, and you can check polarity issues and you can check for overheated cells using the cameras. Troubleshooting on these, well, again, as it says at the bottom, you can see loading switches, fuses, breakers, all these points here all relate to problems that can obviously have a detrimental effect to the full solar panel system. When utilizing thermal cameras, you can see here just a few of the type of errors that you can get. So you can see here that you've got a defective cell, obviously there, it's highlighted, it's not distributing it clearly. Then we've got back problems here as well with defective cells, where you can see we have poor connections, we have resistant connections. All these are attributable factors to why your solar array will not be generating what you expect it to do. So what do we have to use with these? We have a 4-in-1. It's a new tool. It's the IR2BT, which is our irradiance meter. This one, as it shows, will help you to measure the irradiance of that in conjunction with temperature. So obviously we're going to see currents go up here and voltage differences as well. But this is where you look at your full IV curve trace. The illustration on the right-hand side isn't ideal, because with the IRBT2, it actually comes with a fixing bracket. So you can actually put it just off the side of the panel without damaging the panel. But for this purpose alone, they've just decided to position it there to try and give you an illustration. So what do you get? It's apparently, and we like to shout about this, we say it is the perfect companion to use with your SMFT. It does 4 critical tests, as it says. It will measure the irradiance, it will measure the temperature, it will give you an array orientation and a tilt inclination as well. All this is useful and relevant information when feeding into the standards as well. As a clear display for ease of use in direct sunlight. And again, as I mentioned earlier, the BT stands for Bluetooth. So it's able to communicate directly with the SMFT and capture that data and store it so it can be downloaded to the TruTest software. Then we move into combiner boxes. Again, using the solar clamp that we have there, the 393. Looking at ampage measurements there, which are crucial. As it says, they're a quick check to establish whether the PV arrays are operating correctly, and it allows you to test individual arrays as well as looking at the overall status. Now, the 393, I've mentioned it a few times. We shout about this one again because it was the world's first 1500 volt DC Cat 3 rated solar clamp meter. It was bespoke, it was there, and now obviously, like most things, competition obviously catches up. But at the moment, this unit talks seamlessly to the SMFT and allows you to capture and document data there as well. It's got a large thin jaw, as you can see. It's IP54 rated. It captures the DC power measurements, as well as polarity with audible tone and a visual continuity there as well. It comes with all the relevant Pomona adapters for connecting to the solar systems as well. So it's a one-stop tool, basically, and it's a complete functional operational clamp to use and capture the data. Now, when we look at inverter boxes as well, when we could get troubles or issues with these inverters, where we start looking at voltages and irregular incidents taking place, it's where it doesn't produce the right amount of power. So we could utilize a power quality analyzer. I mentioned the 1730 series here, the 36 and 38. We do have higher advanced tools for doing this as well. Again, so it's just to give somebody some entry-level equipment that could help them to make some obviously critical measurements and understand what's coming out of these solar systems and solar arrays. So what do we have? We have a complete portfolio of test and measurement equipment to use in conjunction with our SMFT. We have a clamp meter, the 393. We have the irradiance meter. We have thermal imaging cameras. You can utilize a power quality for understanding what's going on with the output side. And then we could also have an acoustic imager. So again, for the more larger in utility, feeds back onto the grid, you may obviously want to look at additional things like partial discharge. Complementing those, I list them briefly at the bottom. I've not gone into a lot of detail, but battery analyzers, earth ground testers, and again, individual installation testers as well. All these add to an arsenal of Fluke tools to help you test for functionality and safe operation of your solar systems. So just coming to the last couple of slides here, this is what you would get in a solar kit. And I think this is one of the most important slides that we offer. It shows here the backpack with the SMFT. It shows the clamp meter, the irradiance meter, all the connecting leads, extension reels, magnetic sets, all the things that you need to basically walk onto any solar farm and carry out every test that's needed. So I'm just going to sit it there for a second just so you can have a quick look at everything that's there in case you need to ask any questions. As I mentioned, there's also the mounting bracket as well, which you can see just to the 1 o'clock sort of position from center of the illustration. That's a fixing bracket that goes on the side of the solar panel. There's a carry cases there, as you can see, and all the relevant leads and adapters with shoulder straps, etc. So it's a complete one-stop package for everything you need to do for testing all these solar panel array systems. Okay. Right, and the last couple of slides, as mentioned, the first one is for our preferred distributing partner that we have from today's seminar. So I'll just leave this up on screen for a second, please, where you can capture any details and names that you need here. Please feel free to reach out to them as well. These are obviously from all your commercial perspectives, and if you want to utilize or arrange any demonstrations of this test equipment. So I'll just let this sit here just for a minute, just so you can capture the details. Now, if you want to put any questions into the chat, please feel free to do so. If you don't want to do that today, then my details will appear on the next slide. And if you want to reach out to me separately, please feel free to do so, or reach out to Test Meter directly yourself. Okay, hopefully everybody's got that. Again, like I say, this presentation will be made available. Just one quick question, just while we're here as well. Questions come through about the approximate price of the solar kit. All pricing and all commercial issues, I'm going to steer you to test meter if that's okay. My job is just to deliver the information for you, so I don't really want to get into the pricing aspect today. So please feel free to log onto their website or ask the questions directly of those gents, please. And there's just my details. As I say, my name's Marc Sherwood. I'm for the representative for the TSM for the North, and then I've got a colleague, John Reynolds, who's based down south as well. And that concludes our session for today. If you have any questions, like I say, please feel free to reach out to either myself or Test Meter. And after that, I wish you all a good day, and I hope you managed to take something away from this seminar today. Thank you. I'm just going to keep the details on here for another minute or two before I close the seminar off. Many thanks for attending anyway and taking time out of your busy day to join the session. As I said, after you've the session is finished, you should get an email that come through to you with a copy where you're able to download and utilize this as well. Yes, you can take some of information of the slides here. All the information that's been presented today, pardon me, all the information presented today is publicly available online or via our website. So yes, you're free to use this information in ways that you please. Apologies, Brian. How can I purchase a toolbook, or should that be toolbox? I'm not sure what you mean by the tool book, unless you mean the slide deck. The slide deck, as I say, will come to you. If it's a toolbox or a toolkit, please feel free to reach out to Test Meter, sir. Okay, I'm going to leave it just for another minute or so, and then I'm going to draw a line under this then, please. So any further questions, please feel free to drop them in or reach out to me separately away from the presentation. Okay, well, there's no more questions coming through now, so I thank you all for your attendance, and thank you very much today, and I hope you have a wonderful day. Thank you.